This one is for the students learning exponents. I will show you in a way so it just makes sense. When it comes upon a test, you don't be afraid. Listen to my rhymes and you'll be safe. The rules. Hello and welcome to the Kearney Math Show. Thank you all for tuning in today. On today's episode, we are going to be featuring powers to a power and applying what we've already learned about exponents to a new property. Okay, so take just a minute and write at the top of your mini lesson that this is entry number 4. And go ahead and read your learning goal. So entry 4 and read your learning goal. All right, so by the end of today, I want you to be able to explain to, if there was someone who's not here today, I want you to be able to explain to them how to raise a power to a power. And you might even go so as far to teach them the rule, but I want you to be able to understand why the rule works. Okay, so first of all, we're just going to take what we've learned and we're going to apply it to something new. So the top says, using what you've learned, I'm reading right here, about multiplying numbers with powers to find a shortcut for simplifying expressions with powers. Complete each statement by showing equivalent expressions and let your final answer be written as a base raised to a single power. Okay, so when we have 3 to the 6th power, all of that raised to the 2nd power, okay? So that means we're taking 3 to the 6th power and we're squaring it. So literally what we're doing is we're saying 3 to the 6th power times 3 to the 6th power. And we have learned that when you are multiplying exponents that have the same, when you're multiplying numbers that have the same base, what do you do with your exponents? That's right, you add them. So we end up getting 3 to the 12th power. Okay, let's do another one. If we come up under that and we say 2 to the 7th to the 4th power, so 2 to the 7th, all raised to the 4th power, if I were to write that in expanded form, I would have 2 to the 7th times 2 to the 7th times 2 to the 7th times 2 to the 7th, because I'm raising it to the 4th power, so I'm multiplying it by itself 4 times. Okay, so now I'm multiplying all of these numbers with the same base. So what do I need to do with the exponent? That's right, I'm going to add it. So that would be 2 to the, and then if I add 7 plus 7 plus 7 plus 7, that would be 2 to the 28th power. Okay? I'm going to do another one just so you can see if you start seeing a pattern here. So let's go up to number 2. Number 2 says 5 to the 4th, all of that raised to the 3rd power. So I have 5 to the 4th cubed. So if I expand that out, that would be 5 to the 4th times 5 to the 4th times 5 to the 4th. Okay, and we know since they have the same base, I can simply add the exponent, so that would be 5 to the 12th power. Okay, so now what I want you to do is you can actually pause the video and you can go through and finish 1 through 6. Okay, and I know that you're saying, some of you are already starting to see the pattern. Okay, but maybe others aren't, and it's actually really helpful, even if you're seeing the pattern, that you do a few more. So pause the video and try to finish 4, 5, and 6. And I want you to see if there is an easier way that you could do this instead of having to expand it out every time. So pause the video and try 4, 5, and 6. All right. Thank you all for trying 4, 5, and 6. I want us to look at the problems that you just did, and I want you to look at these 2 questions right here. This question and this question. So what it's saying is, what do you notice about the 2 exponents in the original expression? So the 2 exponents in the original expression as compared to the value of the exponent in the final expression. What do you see that their relationship is? Okay, so let's look at another one. Look at these 2 exponents here, and if we compare it to our answer, what do they have in common? 6 and 2 to get 12, or 7 and 4 to get 28, or 4 and 3 to get 12. What do you notice? That's right. Every time the answer is the product of the exponents. So what do you think that you could do? So my next question is, what operation would allow you to go straight from the original exponent to the final one without having to expand it every time? What can you do with those exponents? Exactly. You can multiply them. Okay, and if you're not seeing this, I'm going to work with you a little bit more when you come to my station. So our rule is that, so my rule right here is to simplify a power to a power. Anytime you have a power to a power, you're actually just going to multiply the exponents. Okay? So let's look at number one. I'm going to show you an expanded form, but I'm also going to show you where you can just multiply. Okay? So in expanded form, 2 to the second power, all of that cubed would be 2 to the second times 2 to the second times 2 to the second, which would be 2 to the 6th power. Okay? But what I could have done was I could have just multiplied 2 times 3, and I would have gotten 2 to the 6th power. Okay? So really, when you raise a power to a power, you're just multiplying those exponents. And if you don't see it, then keep expanding it every single time, and eventually you're going to see, oh, that's really what I'm doing. Okay, let's try number 2. C to the 5th power, all of that raised to the 4th power. So that means I'm going to have C to the 5th power 4 times, which means I can just take those two exponents and multiply, so that'll be C to the 20th power. Okay? Now, number 3 is a little tricky. What do you notice now? Instead of just having one base, do you see that number 3 is essentially saying 3a, all of that to the 2nd power. So if we write that in expanded form, that would be 3a times 3a. So then you would multiply your coefficients. 3 times 3 is 9. And a times a, if you added those exponents, would be a squared. So one common mistake is sometimes people just take the square and they just do a squared. But when you have an entire term raised to a power, that power goes to everything inside that term, if it's all in parentheses. So this squared actually should have gone to the a and the 3. And that's how I got my final answer, which was 3 squared times a squared, which is 9a squared. Okay? So let's try another. If you'll flip to the back, I want to try another one where there is a coefficient. So let's look at number 5. So number 5 is 7y to the 4th, all of that squared. So that means that entire thing is squared, not just the y to the 4th. So that squared goes to both terms, the 7 and the 4. It's kind of like distributive property. It really is. You're distributing that squared to everything inside the parentheses. Okay? So that would mean, if we were to expand that out, that would be 7 squared. And then y to the 4th squared, which would be y to the 8th. And then we can simplify 7 squared, which would be 49 y to the 8th. Okay? How are we doing, guys? Can you do one more? Okay, let's do number 6. Number 6, 3ab to the 4th, all of that to the 4th. Okay, so right now you've got to take that 4, and it's got to go to, since everything's in parentheses, it's got to go to everything inside the parentheses. So that means now 3 is raised to the 4th power, a is raised to the 4th power, and b to the 4th is raised to the 4th power. Okay? So essentially I have 3 to the 4th, a to the 4th, and b to the 4th raised to the 4th power, because I've distributed that 4 to everything inside. So now I can simplify 3 to the 4th power. So that'll be 3 times 3 times 3 times 3, which is 36. I'm sorry, 81, excuse me. And then a to the 4th. And then b, that would actually be to the 16th power. Okay? So just to recap what we've learned, anytime you have a power raised to a power, you're going to multiply the exponents, okay? And if you have questions, go back and watch the video and or write your questions down so you can ask me when you come to my station. Or you can write the problems in expanded form and try to simplify it that way if you don't like the rule, okay? So I look forward to working with you at my station. Good luck, guys, and I want you to go ahead and try. You can try to finish the practice on the front, and you can start trying the practice on the back until I ask you to rotate. Go check the answer key after every problem just to make sure you're getting them. All right. Good luck, guys. Make me proud. Peace out, Rainbow Trout. Love you, mean it. Bye-bye.